In this video, I'd like to talk about the math question of the day for March 31st, 2023. And with this equation here, we need to solve for the variable x. We have two logarithmic expressions. One is subtracted from the other, and all of this is equal to 0. So to understand a problem like this, to actually solve this, you will need the tools of Algebra 2, which is when you will typically learn about logarithms and their different properties. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And with this type of equation, there are a couple different strategies. We could use the properties of logarithms. The one that we would need to use is that when we have log, let's say it has base a of b, and we are subtracting log base a of c. When these logarithms have the same base and we are subtracting, we can rewrite this as a quotient of their inputs. We have log base a of b divided by c, where the expression that we're subtracting has an input of c, and that will go in the denominator here. So we could rewrite this as one logarithmic expression and then use the equivalency between exponential expressions and logarithmic expressions to rewrite this as an exponential equation and then solve it from there. So that's one approach. The other approach is just to add this expression to the other side so that we get log base 7 of 3x minus 9 is equal to log base 7 of 2x minus 6. And from here, for this to be true, let's say we have log base m of, let's say, n, and this is equal to log base m of p. For these to be equal, when they have the same base, the inputs must be equal. N must equal p here. So in our case, m is 7, n is this expression, and p is this one here. So the inputs must be equal. We can say that 3x minus 9 is equal to 2x minus 6. And this is just a linear equation which we can solve. We can move all of the x's to one side. 3x minus 2x, that's just x. So you have x minus 9 is negative 6. And adding 9 to both sides of the equation, we just get that x is equal to 3 here. But like I mentioned, we could take this other approach. So let's do that as well, just so that you can see two different approaches to solving this, and you can choose which one you'd prefer. So let me make a little bit of room, and we are going to use this logarithm property. Since we're subtracting, they have the same base, so we can rewrite them as one logarithm where we have a quotient. So we have log base 7, it will have the same base, but now we put this in the numerator, and the one we're subtracting, the input of the logarithm that we're subtracting, we put that in the denominator, and all of this is equal to 0. And we can rewrite this now as an exponential equation, since let's say we have d raised to the e power, and this is equal to f. We can rewrite this as a logarithm where it will have the same base d. The logarithm is equal to the exponent e, and f is the input of our logarithm. So we can always rewrite logarithms as exponential equations, and vice versa. We can rewrite an exponential equation as a logarithm. So let's apply that. And remember, we could just read this logarithm as log base 7 of this input is equal to 0 and interpret it to mean that we're asking 7 raised to what power gives us this input, and that power is 0. So 7 to the 0 power is equal to this input. So let's write that. We have 7 to the 0 is 3x minus 9 over 2x minus 6, but anything to the 0 is just equal to 1. So we have 1 over here. And we'll multiply both sides of the equation by 2x minus 6 so that we can cancel out this denominator. Since when we do that on both sides of the equation, on the right-hand side, it will cancel out. And on the left-hand side, we will just have 1 multiplied by this denominator. But notice this is the exact same linear equation that we had when we used the other method. And so we know that when we solve this, subtracting 2x on each side, adding 9 to the other side, we will get that x is equal to 3. So both methods produce the same answer, which helps us feel confident that we're doing it correctly. However, if we want to know for sure, we can plug it back in to the original equation and check our work. So now we want to check that x is equal to 3, and we have log base 7 of 3 times 3, which is 9, minus 9. And we're subtracting log base 7 of 2 times 3, which is 6. We subtract 6 from that, so both inputs simplify to 0. And if I continue over here, we have log base 7 of 0 minus log base 7 of 0. And something subtracted from itself is equal to 0, which is what we expected. So now we can feel very confident that x is in fact equal to 3.